Okay, so question 2 says the equation B of T equals 3 times E to the D represents the population of bacteria in hundreds D days after it was first counted. Here's the graph. And we need to select all the true statements. So the first thing we need to do is just understand what the graph is talking about. So, and label the parts. So it says that this equation represents the population of bacteria in hundreds. So I'm going to write population of bacteria in hundreds. That's on the side of the graph. So I'm going to put that down there. And then it says that it's counting in D days. So then that's going to be on the other side. So this is the days. So that's the first thing you want to do is make sure you really understand the graph. Now the days is where we're going to plug in the number up here is going to be the days. So when they give us the days, we're going to plug it in here. If they give us the population, we're going to plug it in here and solve. So we need to make sure that we're clear that days is going in for D and this is the population. So A says the ln of 100 is the number of days until the population reaches 30,000. So the ln 100 you may not see anywhere, and you might be, I have no idea where she's getting this from, but we do see it until the population reaches 30,000. So that means that we're going to plug it in for the B of T. So we're going to have 30,000. And I have to do this with my mouse, so sorry about the numbers, equals 3 times E to the D. All right, now be careful because this says in hundreds, so I don't actually want 30,000 written there. So I want to get rid of the 100, so I want to get rid of these 2 zeros. So it's actually 300. So it's actually 300. Oh my goodness, sorry, this is terrible. Equals 3 E to the D. So now we could just solve it and see if maybe we run into the problem of what they mean by ln 100. So the first step I need to do is divide by 3 on both sides. When I divide by 3, I get 100 equals 3 equals E to the D. I'm trying to solve for D, so I need to bring this down to make it a log problem, but it's base E, so that makes it an ln problem. So I'm going to write it as ln 100 equals D. And now that's where they get the ln 100. That's where this came from. So yes, 300, when we plug in 300, meaning 30,000, is going to take the 100 days. So that is true. That's the hardest one. So if you understand that one, that's the hardest one. The rest of them are much easier. So for B, the graph shows that 2 is a reasonable approximation for ln 18. So now that we just did that, we can kind of understand that this is talking about the E. And then when I solve for the population, this is the ln. So this is ln over here. So this is E, this is ln, because remember we talked about that they're the opposite of each other. So then for ln 18, we go up here to ln 18 and we read it across the graph, and I know your copy isn't the greatest, but you can still kind of see that ln 18 is here, and this is not close to 2. This is like 1.8 days. So even though your graph isn't great to read, it's not a reasonable approximation. It definitely needs 2 is more like up here. If you look at 2 is more up here, it's higher than 20. So B is not an answer. C is kind of the same thing as A. They're giving you a value for the population. They're saying 9, which stands for 900, and they want to know if they can write it in this. So it's the same thing. I'm going to divide both sides by 3. When I do that, I get E to the D equals 3. And now I need to make it an ln problem. And when I make it an ln problem, it becomes ln 3 equals D, which is exactly what they're saying. So this is the correct answer. And then D, the graph shows that 10 is a reasonable approximation for ln 1.3. So this one's a trick because if you read it the wrong way, ln is on this side, 1.3 would be like down here. And it doesn't even hit the graph on the positive side, it's somewhere on the negative side. But if we flipped it, which we shouldn't, 1 and 1.3 would be someplace in here, and then 10 would be a good approximation for that. So they're just flip-flopping it. So if it was the other way around, if it said the graph shows that 1.3 is a reasonable approximation for ln 10, yes, that would be true. But since they flip-flopped it, it's not D. All right, that's it.